this tutorial, you will learn how to conduct a chi-square goodness of fit test. You must first have already created a table of counts. Please watch the video on table of counts and pie charts to learn how to make this table first. We will begin by copying our table. We will only need the values, not the percentages, into a new sheet. So we will copy this and add a new sheet. For this test, we want to see if the distribution of the preference for superheroes is equal across all superheroes. So this data that we've collected, this is our table of observed counts. So we will rename this. These are the observed values that we got from our data collected on the survey. The next thing we want to do is make a table of expected counts. So we will do this down below. We can copy and paste this table, and we will delete what we don't need. So these expected counts are what we expect based on our hypothesis. Since we think there will be an equal number of people who like each type of superhero, we expect to see an equal value here for each superhero. Since there were 76 total responses, that means we expect to see 1/4 of them for each of these values. So we will type equals the grand total and divide it by 4, and that will be the expected count for each of our superheroes. In order to drag this down, we need to lock our formula. So on a PC, you can function F4, or on a Mac, you're going to Command T to get those dollar signs around your values. Then we can hit Enter. That means now that we can copy that formula all the way down and it will repeat. The next thing we need to do is create a table for our chi-square statistic. So we'll copy our table of expected counts again. Delete these values, and now we will use the chi-square formula to create our chi-square statistic. So we'll rename this chi-square. The chi-square formula is observed minus expected squared divided by expected. So for each of these cells, we want to have equals the observed value here, 30, minus the expected value for Batman, which is 19. We'll close our parentheses. We want to square that value and then divide it by the expected value again, and then hit Enter. We'll copy this formula down through the other superheroes, and you'll see that by dragging the formula down, it has adjusted for each superhero to the column that goes with that superhero. So it's Superman here. So it's Superman's observed count, Superman's expected count, and that's what's in the formula. The chi-square statistic is the sum of all of these values. So it's the sum of these values here. And we'll see here that we have a very large chi-square statistic. In order to determine if we can reject the null hypothesis or not, we need to find our degrees of freedom and our p-value and chi-square critical value for this test. The degrees of freedom in this test is just the number of categories minus 1. So here we had 4 categories, so 4 minus 1. Our degrees of freedom is 3. To get our chi-square critical value, we'll use a built-in formula, and it's chi sq dot inv, and because we always do a right-tailed test for chi-square, we'll use RT. So the probability here is we want to go with an alpha level of 0.05, and then our degrees of freedom is 3. So our critical value is 7.81. We can see here our chi-square statistic is much larger than that, but we'll also calculate our p-value. So our p-value, and then our p-value is calculated again with a built-in formula. This one is chi sq, and then it's dot dist rt, again using the right-tailed version. When it says X, that's actually our chi-square statistic. So we'll click on 21, And our degrees of freedom, again, is what we calculated here. So we can see here our p-value is extremely small. This e to the negative 0.05, that means our value is 7.98 times 10 to the negative 5, which means we have an extremely small value for our p-value. That indicates we can reject the null hypothesis and include that, in fact, this distribution of superheroes is not equal.